Okay, now we are ready to move to the session 2 of Creational Design Patterns lecture, where we are going to discuss about the factory methods. Factory method is a second example of creational design patterns that we are going to discuss. Okay, factory method design patterns actually aims to do the instantiations of the subclasses during runtime. So we defer the instantiation of the derived classes. So as you can see, this is the structure of factory methods. Let's say they have also the creator and then the product class. So have a creator. This is a creator interface and then the product interface, and then this is a concrete object for the creator and then the concrete product. This looks like the same with the abstract factory method. So abstract factory is have a larger number of classes, and then it's go for the product family. But for the factory method, the aim is just to defer the object instantiation during runtime. So we try to see this example. So the factory method example used to explain about the concept of the factory method. So in this example, we have a remote store manager station. So we have a store 1, store 2, for example, and then we have a different type of computer. So every time we have a new store or the new type of computer, this part of code will be changed. So we have to change. So that's one violates the OCP principle because we have to modify this code. That is the thing that we are going to solve. This is a problem that we are going to solve using factory method design pattern. Okay, so we identify first which part is varies. So here is a part that's require modification. If we have another type of computer, we have to add, for example, HP or Lenovo or whatever. So we have identify the part, this part that will be modified. This part we expect it will be the same, whatever type of computer, whatever the computer type is. So it will be still the same. Okay, to replace the rule of creating an object by this part of code that we remove from this program, we introduce here the create computer method. This is what we call as a factory method. So please note that this is the abstract method that's not implemented in this class. So we if you observe here, this is a public class. So we have to change to public abstract. Abstract class is different from interface class. For interface class, we don't have implementation at all, but for abstract class, we have implementation. For example, display computer method here. And then please also notice that in the abstract factory design patterns, we pass the object here, but now we just mention the type, and then we create the object using this create factory methods operation. So create computer, we pass the type, and then it will go to create the computer object, and then perform the operation, which is uniform throughout the concrete class. So here back to the factory method example. So we already modify some part of the part of the code that varies. So we try to see back about the problems that we have in hand to solve. So we have a computer store 1, store 2, and then it's possibly the new store. Maybe new type HP type that sell the PC. So in order for this remote store manager station to access the new one to add, so we don't want, we want to reduce the code in the main code here. So we just that's why we use the factory method. So this is back to the original problem that we want to solve. So we continue with the solution. This is our solution. the design for factory method design patterns that solve the computer store problem. We have a creator class, and then we have also the product classes. So here is the interface classes, here is the abstract class. So the abstract class is implemented here for the what we call the abstract method. So factory method is a abstract method. So it's implement here, not implement here, not implement in the computer store object in this abstract class, but the concrete class is implemented there. Okay. So this one is the set of concrete classes for interface. So for interface, there is no implementation at all. It's only purely interface. All the methods need to be implemented in the concrete classes. Okay, so this is the code, sample code for the display computer. So display computer have a string type, what type of computer. So when you create the computer, so it will depends what type. So Dell. So it is we don't know about the type during compile time. We just know during runtime. So this one is expected to be the same. Okay, we have completed the implementation of the display computer in the computer store abstract class. Now we are going to continue to see how we can implement the create computer in the standard computer store, which is an abstract class for this, which is a concrete class for this abstract class. So it is implemented, the create computer implemented in the standard computer and then also in advanced computer. So it is not implemented inside the abstract class because it is an abstract method. So here the implementation for the create computer, it's receive the type here. It is optional parameter. It can be leave empty because we have a null computer type. If there is no what we call it, you can put null because it can have a default value like that. So currently we have a standard, for example, a standard computer, let's say. So at the moment, so in future, let's say we are this store will support the new type of computer, for example Dell and Mac. So we just add this piece of code, this part inside the here in the standard computer store class. So this is how it works. So we don't have to modify the computer store class, just modify the implementation here. Okay, so this is how the factory methods works. This is for the advanced computer. We also implement the create computer method inside the advanced computer store class. So we have for example Mac. It's different from if we see standard, Dell and Mac. So this one only offer Mac, so just MacBook Pro, for example. And then it also have a null computer as a default because it is optional here. So if you see here, this is the main program that utilize the factory method implemented for the computer store. Okay, so this is the option, for example New York store, Florida store, and then we can add the store in this program as we have more stores, but we don't have to modify the code inside the computer client. Okay, so this is the to see in the diagram where another one is added for the null computer here. For the null computer, actually if there is null object given as a parameter, so it will produce this does not carry the type of the null is used to cater for any other inputs type for the computer CPU. So it will go to this part. If the option is not not available, so it will go to the null computer implementation. So this one we call it as also the null object pattern example. So this is a null object pattern. Null object to cater something other than what's defined here, here, and here. And for example, if you go to the that type of computer, and then we prepare just like to cache something input that's other than the valid inputs. Okay, so we finish the factory method design pattern discussion with the example. So the steps, if you still remember what we have done in this session, we identify and design the product interface, identify the design concrete products, and then design the factory interface for the factory method with one abstract factory interface method. And then we change the class to the abstract class, and then implement the concrete class. So design one or more concrete factories for each product identified in step 2, and then associate each factory from step 4 with respective product from step 2. So benefits of the factory method pattern is to separate code from product specific classes, and therefore the same code can work with various existing and newly created product classes. So this is similar to the abstract factory method. Abstract factory patterns. So by separating the code, development becomes efficient, and then since different developer can work in different parts of the project, and then they can supply the compiled code, and then we just attach to our program. So we don't have to change the computer client in this example, for example. So by separating the code, it becomes easier to reuse and maintain the parts of the code. So with that, we end the discussion on factory method, and then next we'll move to the other types of creational design pattern.